How old could the Milky Way possibly be? Well, we're going to answer it in this video. Now we begin our presentation.
This is going to make you freak.
We certainly know that our universe exists. However, this knowledge alone has not quite satisfied mankind's quest for further understanding. Our curiosity has led us to question our place in the universe and, furthermore, the place of the universe itself. Throughout time, we have asked ourselves these questions. How did our universe begin? How old is our universe? How did matter come to exist? Obviously, these are not simple questions. And throughout our brief history on this planet, much time and effort has been spent looking for some clue. Yet after all the energy that has been expended, much of what we still know is only speculation. Still only speculation. We have, however, come a long way from the mystical beginnings of the study of cosmology and the origins of the universe. True to the nature of science, a majority of these answers have only led to more intriguing and complex questions. It seems to be inherent in our search for knowledge that questions will always continue to exist. How old is the Milky Way? When did the first stars in our galaxy ignite? Our sun and its planetary system was formed about 4,560 million years ago, but many other stars formed much earlier. Some of the oldest stars in the Milky Way are found in large stellar clusters, in particular in globular clusters. Stars belonging to a globular cluster were born together from the same cloud at the same time. Since stars of different masses evolve at different rates, it is possible to measure the age of globular clusters with a reasonably good accuracy. The oldest ones are found to be more than 13 million years old. Still, these cluster stars were not the first stars to be formed in the Milky Way. We know this because they contain small amounts of certain chemical elements which must have been synthesized in an early generation of massive stars that exploded as supernovas after a short and energetic life. The processed material was deposited in the clouds from which the next generations of stars were made. We do not know when these first stars were formed. For the time being, we can only say that the Milky Way must be older than the oldest globular cluster stars. But how much older? Beryllium, one of the lightest elements, came to the rescue. Beryllium can only be produced by cosmic spallation, by being fragmented and originating in supernova explosions and referred to as energetic galactic cosmic rays. The galactic cosmic rays traveled all over the early Milky Way, guided by cosmic magnetic field. The resulting production of beryllium was quite uniform within the galaxy. The amount of beryllium increased within time, and this is why it might act as a cosmic clock. The longer the time that passed between the formation of the first stars, or more correctly, their quick demise in supernova explosions, and the formation of the globular cluster stars, the higher was the beryllium content in the interstellar medium from which they were formed. Thus, assuming that this beryllium is preserved in the stellar atmosphere, the more beryllium is found in such a star, the longer is the time interval between the formation of the first stars and this star. The beryllium may therefore provide us with unique and crucial information about the duration of the early stages of the Milky Way. According to the best current spallation theories, the measured amount of beryllium must have accumulated in the course of 200 to 300 million years. Italian astronomer Daniele Galli said, "So now we must know that the age of the Milky Way is this much more than the age of that globular cluster. Our galaxy must therefore be 13,600 plus or minus 800 million years old. This is the first time that we have obtained an independent determination of this fundamental value. Within the given uncertainties, this number also fits very well with the current estimate of the age of the universe, 13,700 million years. That is the time elapsed since the Big Bang, and thus it appears that the first generation of the Milky Way galaxy was formed at about the time the Dark Ages ended, now believed to be some 200 million years after the Big Bang. It would seem that the system in which we live in might indeed be one of the founding members of the galaxy population in the universe. Yeah, so that's all I've got for now.
For now.